Okay, so good, good evening for everyone. Today the fourth session of the lecture session. So today we will talk about the operating systems. So the operating systems are the con- cornerstone of the modern computing, servicing and the essential software layer that bridges the gap between hardware and application. They manage hardware resources, provide a user interface, and enable software to run efficiently. Without an operating system, computers would be unable to perform even a most basic task. As well as operating systems are the unsung heroes of computing, providing the foundation upon which all software and hardware rely. From managing resources to enabling innovations, they play a critical role in shaping the digital world. As technology continues to evolve, operating systems will be remain at the forefront, adapting to new challenges and opportunities. Understanding their principles and function is essential for everyone interested in computer science, software development, or IT. So the operating system is a application or a something like the system software which is connecting the hardware and user interface for the uh, perform the performances of the task between hardware and user interfaces. So the uh, now we will talk about what is an operating system. An operating system or a OS is a software program that act as an intermediate intermediary between computer hardware and the user. It manages the hardware resources, provides a platform for running application, and ensure that the computer system operate efficiently and securely. Without an operating system, a computer would be unable to perform even a most basic task, and user would have no way to interact with the hardware. So the component of operating systems are uh, will be kernel and a system library, system utilities, and user interfaces. So the kernel is the core of the OS, and the kernel manages system resources and facilities communication between hardware and software. It is handles tasks like process scheduling, memory management, and device communication. The system libraries are pre-written code module that provide common function for applications such as input and output operations or mathematical calculations. So then we will talk about the system utilities. System utilities are tools and programs that help manage and maintain the system, such as disk cleanup, file management, and the system monitoring tools. User interface mean the part of the OS that allow users to interact with the system either through CLI, it means terminal, or a GUI. GUI mean graphical user interface. For the CLI, mostly terminal in Linux, and the GUI will be the Windows desktops or a Windows operating system. And now we will talk about the history and the evolution of operating system. The history and the evolution of operating system reflect the advancement in computing technologies over the decades. Operating systems have grown from simple programs that manage basic hardware operations to complex systems that power everything from personal computers to smartphone and cloud servers. Hence, uh, so we will talk about the how the operating system, how that development in 1940s. No, there was no operating system. early computers, we known as early computers. The first electronic computers, such as a ENIAC, had no operating systems. Programs were manually entered using a punch card or switches, and each program had to manage hardware resource directly. And this is single user systems, that computers were used for one task at a time, and users had to manually load and run programs. After that, in 1950s, batch processing system was introduced. So to improve the efficiency, batch processing systems were introduced. Users submitted jobs like programs and data from on punch cards, and the computer would process them sequentially without user interaction. So the IBMS in 1956 is considered one of the first operating system designed for the IBM 704 mainframes. In 1960, time sharing and multi-programming was introduced. So the time sharing systems mean time sharing allow multiple users to interact with the computer simultaneously. The OS would quickly switch between tasks given the illusion that all users had dedicated access. So the multi-programming mean this concept allowed multiple programs to reside in memory at the same time, improving resources utilization. Examples for it: CTSS, like compatible time sharing system in 1961, one of the first time sharing system. In 1969, unique UNIX a system was developed at Bell Labs by Thompson and Dennis Ritchie. Unix introduced many foundational concepts such as hierarchical file system and command line interface. We are otherwise we called as it CLI. In 1917s, uh, rise of personal computing and modern OS concept in 1970. So the mini computers and mainframes, operating systems like Multics simply form. The complex version is multiplexed information and computer services, and VMS, virtual memory systems, introduced advanced features like virtual memory and security. In the Unix evaluation, Unix became widely adopted in academic and commercial settings, leading to development of variant like BSD, Berkeley software distributions. So, in 1917s, personal computers were introduced, and in 1970s saw the birth of personal computing with the operating system like CP-M control program for mini computers, paving the paving the way for early PCs. So in 1950, graphical user interfaces and commercial OSs has been uh, come to the industry. So GUIs mean graphical user interfaces made computers more accessible to the non-technical users. Apple Macintosh system software in 1984 and Microsoft Windows was introduced in 1985. So the next MS-DOS, Microsoft Disk Operation Systems, became the standard for IBM compatible PCs. Then Unix commercialization was also there. Companies like Sun Microsystems and HP developed commercial Unix-based system for workstation and servers. In 1990, network computers and open source was introduced. Windows dominance. It means Microsoft released Windows 95, which brought a user friendly GUI and multitasking compatible to the masses. Later versions like Windows NT introduced support for networking and enterprise environment. In 1991, Linux was introduced and it was introduced by Linus Torvald released the first version of the Linux kernel, which combined the GNU software, became a powerful open source operating system. As well as next mobile operating systems was early mobile OSs like Symbian and Palm OS emerged, laying the groundwork for modern smartphones. In 2000, in 2000, mobile and web-centric OSs was introduced. So the 2000s saw the rise of mobile operating system like iOS 2007 and Android in 2008, which revolutionized personal computing with the touch screen and app ecosystems. Cloud computing is a operating systems began to adapt the cloud environment, with Linux becoming the dominant OS for the servers and cloud interfaces. Virtualization technology like VMware and Hyper-V enabled multi operating systems to run on single physical machine, improving the resource utilization. In 2010, the present modern trend, mobile dominations, iOS and Android became the most widely used operating system globally, powering billions of smartphones and tablets. Cloud native OSs like operating systems like Chrome OS and uh, Chrome OS and containers focused OSs like Core OS emerge optimized for cloud and web-based applications. So, next, IoT and emerged systems like lightweight OSs like FreeRoots and Zipa were developed for IoT devices. Operating system began integrated AI capabilities for tasks like predictive analysis and resource optimizations. In quantum computing, research into operating system for quantum computers began aiming to manage quantum hardware and algorithms. So, So in the decades, like key developments, we will summarize this. In 1940s, there's no any OS and manual programming was there. In the 1950s, batches processing systems was introduced, and 1960 time sharing and multi-programming Unix was introduced, and 1970s personal computing like CPM and Unix variants was introduced. In 1980s, GUIs, MD-DOS, and Macintosh system software was introduced. And in 1990s, Windows 95, Linux, early mobile OS was introduced. In two, In 2000s, iOS, Android, cloud computing, and virtualizations was introduced. In 2010, to present, mobile dominations, cloud native OSs, and IoT, as well as AI integrations was came to the industry. So the history of operating system is a story of continuous innovations driven by the need to manage increasingly complex hardware and software. From batch processing the processing in the 1950s to the modern cloud native and AI powered systems, operating systems have evolved to meet the demands of each era. Today, they are more versatile and powerful than ever by enabling everything from personal computing to global scale cloud infrastructure. Understanding these evaluations provide a valuable insight into the future of computing and the role of operating systems in shaping it. So the next we will talk about the key functions of operating systems. So the key function of an operating systems are like resource management, process management, memory management, file system management, device management, security and access control, user interface are the key components or key functions of an operating system. So the resource management is the OS manage hardware resources such as the CPU, memory, storage and other hardware components. So it ensures that these resources are allocated efficiently to running the applications. So the process management part of process management part will be the OS handles the creation, scheduling, and termination of processes like program in executions. So it ensures that each process get adaptive CPU time and manage multitasking. So memory management will be the OS oversees the allocation and deallocation of memory, ensuring that applications have the resources they need while preventing conflicts. Next one will be the file system management. The OS organize and manage file on storage device, providing a hierarchical structure for data storage and retrieval. So the device management means through the device drivers, the OS communicate with hardware components like printers, keyboards, and display, enabling user interaction. Security and access control mean the OS enforce security policies, manage user permissions, and protect the system from unauthorized system access. So the user interface, the OS provide the interface for users to interact with the system whether through command line or graphical user interface GUI. Now we will talk about the uh, types of operating systems. So the operating systems comes in various types, each designed to meet specific needs and use cases. They vary in complexity, functionality, and environments they support. So we will talk about the first. We will talk about the batch operating system. Batch operating system process jobs in batches where users submitted jobs. Jobs mean the program or a data to be executed without direct interaction. Characteristics, user cases. uh, so the examples will be IBM OS like 360. So next we will talk about time sharing operating system. Time sharing systems allow multiple users to share computer resources multinously by rapidly switching between tasks. So the characteristics will be provides the illusion of dedicated access to each users and use CPU scheduling and multitasking. So examples will be Unix, Multics. Next one, distributed operating systems. Distributed OSs manage a group independent computers and make them appear as a single system. They enable resources sharing and communication across networked systems. So the characteristics will be resources like storage, memory and processing are shared. and high faults tolerance and scalability is there. Examples for this: Google, Chrome OS, Apache, Hadops. Next, network operating systems. Network OSs are designed to manage and coordinate network computers, providing shared access to resources like file and printers. So, characteristics of this will be centralized server management and provide security and user authentications. Examples will be Microsoft Windows servers and novel NetWare. Real-time operating systems. We are calling RTOS. So the RTOSs are designed for systems where time critically operations are required. They ensure tasks are completed within strict time. So the just a moment. So the characteristics will be of RTOs are predictable and fast response time and used in embedded systems. So the use cases of this RTOs: robotic automotive systems, industrial automations. Examples will be free RTOS, VxWorks. Next, we will talk about mobile operating systems. Mobile OSs are designed for smartphones, tablet, and other portable devices. They are optimized for touch screen, battery life, and app ecosystems. Characteristics will be user-friendly interface is integrated with the mobile OSs and the support for apps and connectivity features like Wi-Fi, Bluetooth. So the examples for mobile OSs are Android, iOS. Next, we will talk about embedded operating systems. Embedded OSs are lightweight and designed for specifically hardware in embedded systems such as IoT devices and applications. So the characteristics will be low resource consumptions and tailored to specific tasks. So examples for this is embedded Linux and CPU. Next, we will talk multi-processing OSs. These OSs support systems with multi-CPUs or cores, allowing parallel process of tasking with the characteristics of improved performances and throughput, as well as efficiently resource utilization. So the example is Linux and Windows 10, or Windows 10, Windows 11, and the Windows desktop OSs. Next, we will talk about the desktop OSs. Mainly, when we talk about the desktop OSs, mainly examples will be Windows, Mac OS, and Linux distributions like Ubuntu. So the desktop OSs are designed for personal computers and workstations, providing a user-friendly interface and support for a wide range of applications. With the characteristics of GUI-based interfaces, support for productivity, gaming, and multimedia applications. So next we will talk about the server operating systems. Server OSs are optimized for managing network resources, hosting applications, and handling large-scale data processing. Like with the characteristics, high scalability and security, support for multiple user and services. So the examples for the server OSs are Linux distributions like CentOS, Ubuntu servers, and Windows servers. Next, we will talk about cloud operating system. Cloud OSs are designed to run in cloud environment, providing virtualization, scalability, and remote access to resources. With the characteristics of centralized management of resources and support for virtual machines and containers. examples will be Google Chrome OS and VMware vSphere. So, operating systems are categorized based on their designs, functionality, and the environment they support. From batch processing system to modern cloud and mobile OSs, each type serve a unique purpose in the computing ecosystems. Understanding these types help in selecting the right OS for the specific applications, whether for the personal use or either enterprise environments, either specialized systems like IoT or real-time computing. Next, we will talk about Windows desktop operating systems. So basically, uh, Windows desktop operating systems are a family of operating systems developed by Microsoft for personal computers, laptop, and workstations. Since it introduced in 1985, Windows has become one of the most widely used desktop operating systems, globally known for its user-friendly interface, broadened broader software compatibility and regular updates. So, evaluation of Windows desktop, early version of the Windows will be Windows 1.0 in 1985. In 1987, Windows 2.0 introduced. In 1990s, Windows 3.0 introduced. In 1992, Windows 3.1 and was introduced. So Windows 9X series was introduced in 1990s. So now in 1995, Windows 95, in 98, Windows 98, and 2000 Millennium Edition was came under Windows ME. Then also in 90s, Windows NT series was released. Windows NT means network side, network management one. In 1993, Windows NT 3.1 was introduced, and in 2000, Windows 2000, and in 2001, Windows XP was introduced. So, modern Windows was introduced in 2000 to present. So, in 2007, Windows Vista, 2009, Windows 7, and 2012, Windows 8, in 2013, 8.1, and 2015, Windows 10 was introduced, and 2021, Windows 11 was introduced. So, and so next we will talk about the advantages of Windows desktop operating systems. So one advantage is wide software support. Windows support a vast range of applications from productivity tools to games. Then hardware compatibility, user-friendly interface, regular updates, and gaming ecosystems are the advantages. Disadvantages of Windows desktops are security vulnerabilities, bloat, bloatware, resource usage, and privacy concern. I will talk about the security vulnerability. So when a OS is released, and they are regularly sending us some updates. This is common for Windows desktop OSs and the Windows Server OSs. So in the patch releasing date is from the Microsoft, we are telling it as Patch Tuesday. It is released every month, second Tuesday. So that day is called Patch Tuesday for Microsoft. So they will release a security patch, cumulative updates, and some integrated things to the OS by providing a plugin. Plugin mean it's a security patch. So it will be released on the patch Tuesday, and once it released, we will install it over our operating systems to avoid security vulnerabilities. Next, we will talk about the Windows Server. Windows Server is a family of server operating system developed by Microsoft, specifically designed to manage and support enterprise-level IT infrastructure. It provides a robust platform for running networked applications, managing data, and delivering services such as file sharing, web hosting, and virtualization. Windows servers is widely used in business of all size, from small organization to large enterprise, due to its scalability, security, and integrated with other Microsoft products. Evaluation of Windows servers are: in 1993, Windows NT Server; in 2000 Windows Server 2000 was introduced, and next Windows Server 2003, Windows Server 2008, and Windows Server 2008 R2, Windows 2000, Windows Server 2012, 2012 R2, Windows Server 2016, Windows Server 19, Windows Server 2022. In the latest, they have introduced Windows Server 2025. But now the Microsoft has been dropped to support Windows Server below 2016, like 2012, 2012 R2, 2008, 8 R2, 2003, and 2000 and 1993 servers are dropped by Microsoft to provide the support, because those are older OSs. Next, we will talk about the features and capability of Windows Server. Windows Server is a powerful and vast operating system designed by Microsoft to meet the needs of modern enterprise IT environment. To it provides a robust platform for managing networked applications, data, and services, making it an essential tool for business of all sizes. So the key features were like Active Directory. Active Directory is a centralized management where directory services that enable centralized management of users, computers, and other resources in network environment. Authentication and authorization provides secure authentication and role-based access RBAC for users and devices. Also, it provides group policies, allow administrators to enforce security and configuration settings across the network. Then we will talk about the Hyper-V virtualization. Hyper-V is a hypervisor-based virtualization platform that allows engineers to create and manage virtual machines on a single physical server. And it enabled efficient use of hardware resources by running multiple VMs or virtual machines on a single server. Cloud and hybrid cloud support integrate with Microsoft Azure for seamless hybrid cloud scenarios. Also, it next role is storage solutions, like storage spaces virtualization feature that allows you to pool physical disks and create virtual disks within redundancy and performance optimization. Resilient file system, a modern file system designed for high reliability, scalability, and data integrity, ideal for large data volume. Storage replica provides synchronization or asynchronization replication for disaster recovery and high availability. Next feature is security features. So the Windows Defender Advanced Threat Protection ATP provides advanced threat detection and response capability for servers. Shield virtualized machines protect VMs from unauthorized access and tempering tempering. Secure boot ensure that only trusted software runs during the boot process. Encryption support BitLocker for full disk encryption and HTTPS for secure communication. Next, networking. Software-defined network (SDN) simply simplify network management and automation, allows for flexible and scalable network configuration. Under networking, DNS and DHCP is there, and remote access like support VPNs and direct access for secure remote connectivity. And web and application hosting also a feature of Windows Server. Internet IIS is flexible and secure web service for hosting websites and web application. .NET Framework support enables the development and deployment of enterprise applications. High availability and disaster recovery. This is under this failover clustering provides high availability for critical applications by grouping servers into clusters. Storage replica enables data replication between servers for disaster recovery and business continuity. Capability of Windows servers are scalability, flexibility, reliability, security, integration with Microsoft ecosystem, modern application support. So, Windows Server is a comprehensive and powerful operating system that provides the foundation for modern enterprise IT organizations to build secure, scalable, and efficient IT environments. Whether uh, the customer managing a small business or a large enterprise, Windows Server offers the tools and flexibility to meet your needs. So next we will talk about the deploying and managing Windows Server. So deploying and managing effectively is crucial for ensuring a secure, scalable, and effective IT infrastructure. Whether you are setting up new server environment or maintaining an existing one, understanding the deployment and management process is essential. So, planning and first one is planning and preparation. So the before deploying Windows Server, proper planning is necessary to ensure smooth implementation. Key considerations for the planning and preparation. Hardware, we need to consider the hardware requirement, ensure the server hardware meets the minimum requirement for the chosen Windows Server versions like CPU, RAM, storage. Then licensing part should be considered. Choose the appropriate editions, standard or data center, and license model based on the your organization need. Next, we need to consider the networking configurations like plan IP addressing, DNS and DHCP settings, role and features. We need to identify the roles like Active Directory, Hyper-V, and features like PowerShell in failover cluster require for the environment. Also, we need to plan backup and recovery modules like develop a backup and disaster recovery plan to protect critical data. Next, we will talk about the deployment options. Windows Server can be deployed in various ways depend on your requirement. It means we can deploy the servers installation method or network installation, virtualization, so on. So the installation methods are use DVD or USB drive to install Windows Server on physical hardware. Network installations mean deploy over network using Windows deployment services like WDS. Virtualization means install Windows Server as a virtual machine using Hyper-V, VMware, either or hypervisor. Or next, cloud deployment. Deploy Windows Server into the cloud using Microsoft Azure or other cloud provider. Installation types are server core, and desktop experience. Server core means a minimal installation option with no GUI. It means there's no any graphical user interface. It using only CLI. Idle for reduce the overhead and improved security. Then the desktop experience means a full installation with a graphical user interface like with GUI suitable for users who preferred a visual interface. Initial configuration after installation, configure the server to meet your organization needs. Key configurations and tasks are set the hostname. Hostname is the assigning a full meaningful name to the server to identify when it managing. Configure network like set up IP addresses, DNS, and gateway settings. We need to join a domain. We need to create a domain and we need to join the machine servers and other things. Sorry. Uh, Join in domain, we need to create a domain with a meaningful name, specific for your industry, if specific your environment, and we need to add the server to an active directory domain if applicable. Enabling remote management by configuring remote desktop protocols. Just a moment. Configure remote desktop protocols like RDP or Windows Admin Center for remote administration. Install the roles and features. Use Server Manager or PowerShell to install required roles, Active Directory, Hyper-V, and other features. Next, managing of Windows Server. Effective management ensures the server operates efficiently and securely. Management tools like Server Manager, Windows Admin Center, PowerShell, and Group Policy Management. Key management tasks will be user and group management, monitoring and performances tuning, patch management, backup and restoration, security management. Then the advanced feature and scenarios, virtualization with Hyper-V. Create and managing virtual machines to optimize resource utilization. Use features like live migration and storage migration for high availability and flexibility. Failover clustering, group multiple servers into clusters to provide high availability for critical applications. Configure shared storage and quorum settings for cluster scalability. Best practices for deploying and managing Windows servers are we need to document everything, regular updates, monitor performances, and important secure best practices, test backups, and plan for scalability. So the deployment and managing Windows Server requires careful planning, configuration, and ongoing maintenance by leverage the right tools and following best practices. Engineers can build a secure, scalable, and efficient server management that meets the organization needs. Whether you are managing a small business or a large enterprise, Windows Server provides the flexibility and features to support a wide range of workloads and applications. With its robust management tools, advanced features, and integration within the Microsoft ecosystems, Windows Servers remains a cornerstone of modern IT infrastructure. Now we will talk about securing and optimization of Windows Server. Securing and optimization of Windows servers is a critical to ensure reliable, high performances, and secure IT environment. As the backbone of enterprise infrastructure, Windows servers must be protected against threads and fine-tuned to deliver optimal performances. Below is a so next we are going to talk about the security in Windows servers. Implement strong authentication access control, use complex password, and we can use multi-factor authentication for the administrative accounts to add an extra layer of security. Then role-based access control, assigning permissions based on user roles to limit access and sensitive data systems. Disable unused accounts, regularly review and disable inactive or unnecessary user accounts. Hardening the server configurations. It means server core installation. Use the server core installation option to reduce the attack surface by eliminating the GUI. Disable unnecessary services. It means turning off services that are not required for the server, or like printer, print spoiler on the web servers. Configure firewall rules. Use Windows Defender Firewall to block unauthorized access and allow only necessary traffic. Enable secure boot. Ensure that only trusted softwares run during the boot process. Keep the system up to date. Regular patching, like previously I have told, over the second Tuesday, Patch Tuesday, patches are released. So we need to install those patches regularly with the latest security updates and patches from Microsoft to address vulnerabilities. We can configure automatic updates. It will be automatically downloading and installing required updates. And protection, protect data with encryption. So we can use BitLocker. Use BitLocker to encrypt entire drive and protect data at rest. HTTPS, enable HTTPS for web services to encrypt data in transit, and EFS, like encrypted file system, to encrypt sensitive files and folder using EFS. Next one is monitor and audit security. Windows Defender ATP use Windows Defender Advanced Threat Protection to detect and respond to threats from the event viewer. Regularly, we need to review security logs in event viewer to identify suspicious activity, as well as audit policies enable auditing for critical event like logon attempts and file access. And implement network security with network segmentations. Isolate critical servers using VLANs or firewalls. VPN direct access. Use secure remote access solution for administrators. DNS security. Configure DNS settings to prevent spoofing and other attacks. Optimization of Windows Server. Optimizations of Windows Server. Optimize performances. Monitor resources usage. Use tools like Task Manager, Performances Monitor, and Resource Monitor to track CPU, memory, disk, and network usage. Upgrade hardware by adding more RAMs, faster storage like SSD, or additional CPUs to improve performances. Disable unnecessary startup programs by reduce startup time and free up resources by disabling unnecessary programs. Fine-tune storage, like storage spaces. Use storage space to pool disk and improve storage performances and redundancy. REFS. Use REFS for large volume to improve reliability and scalability. Defragmentation. Regularly defragment hard drive if using HDDs to improve performances. Optimization of virtualization, like Hyper-V. Dynamic memory. Under dynamic memory, enable dynamic memory to allocate RAM efficiently to virtual machines, VMs. And live migration. to move VMs between hosts without downtime. Storage optimization like storage QoS and storage replica to optimize storage performances and availability. Backup and disaster recovery. Regular backups, we need to use regular backups. Use Windows Server Backup or third-party tool to perform regular backups of critical data. Test restoration, test backup to ensure data can be restored in case of failures. Disaster recovery plan, develop and document a disaster recovery plan to optimize downtime and data losses. So, secure and optimizing the Windows Server is an ongoing process that requires a combination of best practices, tools, and proactive management. By implementing a strong security measures, fine-tuning performances, and maintaining regular backups, you can ensure that your Windows Server environment remains secure, reliable, and efficient. Whether you are managing a single server or a large enterprise infrastructure, these strategies will help you maximize the value of your Windows Server deployment while minimizing risk. Then migration to latest Windows Server versions. This is a critical process for organizations looking to task advantage of new features, improved security, and enhanced performances. Whether you are upgrading from an old version to Windows Server or migrating from different platform, careful plan and execution are essential to ensure a smooth transition below in transition. So the first we need to assess the current environment before starting the migration. Evaluate the existing infrastructure to identify dependencies, workloads, and potential challenges. So next, plan and migration. A well-defined migration plan minimize downtime and reduce the risk of issues during the transactions. Key consideration is choose the migration strategy. Decide between an in-place upgrade or a side-by-side migration. Or next, set a time. We need to set a timeline by defining a timeline for migration, including testing and rollback plans. Assigning roles and responsibilities. Identify the team members responsible for each perhaps of the migration, backup data, perform a full backup of critical data and configuration before starting migration. Prepare for the migration. Ensure the environment is ready for the migration by addressing prerequisites and potential issues. Key steps for this: update firmware and drivers. We need to test applications, prepare the new servers, and document configurations by server configurations, including network settings, roles, and features. Then perform a migration. Execute the migration according to the plan which was documented by ensuring minimal disruption to the operations. In place upgrade, run the Windows Server setup. Launch the installation media for the latest Windows Server version on the existing server of old version. We can choose the upgrade options. Select the option to upgrade the existing installation and next follow up the prompts. Verify functionalities. Then side by side migration is first set up the new server, migrate roles and features, then migrate data. Then reconfigure the application and do the test over the new server. Post migration task will be After the migration, perform additional setup to ensure the new environment is secure and optimized. Key setups will be update security settings, monitor performances, decommission in the old servers, and update documentations. Best practice for the migrations are test thoroughly, communicate with stakeholders, plan for rollback, leverage automations, monitor post migrations. Tool for the migrations will be used from the Windows and Windows Server migration tool, storage migration tools, Azure Migrate, and Windows Admin Center. Migration to the latest Windows Server versions is a strategic move that can enhance your organization's IT infrastructure with new features, improved security, and better performance. Like the Windows Server OSs which were released, it means not supported, like 2012, 2012 R2, 2008, 2008 8 R2. We are migrating those servers to the latest versions like 2019, 2022, or 2024. When we are doing these things, we need to ensure the access compatibility. We need to plan and test, execute migration and validation and optimizations. Next, we will talk about Linux and open source operating systems. So this have evaluationized the world of computing by providing free, customizable, and community-driven alternative to properties software. Like Linux, in particular, has become a concern of modern IT infrastructure, powering everything from server and supercomputer to smartphone and embedded devices. What is a Linux? Linux is an open source, unique Unix-like operating systems kernel developed by Linus Torvalds in 1991. When combined with software from the GNU project and other open source projects, it forms a complete operating system known as Linux distribution distro. Key features of Linux will be open source, modularity, and scalability and security, and multi-users and multitasking. The open source movements. The open source movement advocates the software that is freely available for use, modifications, and distributions. Key principles include collaboration, transparency, and freedom. The open source license. GNU General Public License GPL ensure that deviate work remains open source. MIT license permit reuse within proprietary software. Apache license allow modifications and redistribution within specific parent protections. Popular Linux distributions package the Linux kernel within system libraries, utilities, and software to create a complete operating system. Some popular distro include like Ubuntu, general purpose distributions like Ubuntu, Fedora, Debian, Linux Mint. Enterprise and server distributions are Red Hat Enterprise Linux, we call RHEL, and CentOS, SUSC Linux Enterprise, and Ubuntu servers. Lightweight and minimalist distributions like Puppy Linux, Lubuntu, Arch Linux. Security focused distributions like Kali Linux, Tails, and Parrot. For the advance of Linux and open source operating systems, advantages of this is cost efficiency, customizability, security, and community support, and versatility. Linux in the modern world, like in servers and cloud computing, Linux powers the majority of web servers, cloud infrastructure, and data centers. Supercomputers, all of the world's top 500 supercomputers runs on Linux. Mobile devices, Android, the most popular mobile operating system, is based on Linux kernel. IoT, Linux is widely used in IoT device, use its lightweight and customizable nature. So challenges of Linux and open source operating systems are learning curve. Linux can be challenging for beginners, especially those accustomed to property systems like GUI. Software compatibility. Some proprietary softwares and games are not native support on Linux. Fragmentations. The wide variety of Linux distros can lead to compatibility and support issues. So the Linux and open source operating systems have transformed the computer landscape by providing free, flexible, and secure alternative to proprietary software, from powering the internet and cloud infrastructure to enabling innovation in the mobile and IoT devices. Linux distribution and variety and versatility. So the Linux operating systems each tailored with meet specific need, performances, and user cases. These versatility and variety of Linux distros make them suitable for wide range of applications, from personal computing to enterprise servers, embedded systems, and beyond. So the key features of Linux distributions are open source, customizability, stability, and security, wide hardware support. Categorization of Linux distributions are general purpose distributions like Ubuntu, Fedora, Debian, Linux Mint, enterprise server distributions like Red Hat Enterprise Linux, CentOS, SUSE Linux Enterprise, Ubuntu servers, lightweight and minimalist distributions like Puppy Linux, Lubuntu, and Arch Linux. So this for the security focused distributions like Kali Linux, Tails, Paratois. Specialized and night distributions like Raspberry Pi OS, Steam OS, Scientific Linux. For roll-in and release distributions, Arch Linux, Manjaro, OpenSUSE, Tumbleweed. Then, for the popular desktop environments, Grown KDE Plasma, XFCE, LXQT, and Cinnamon will be there. Why we need to choose a Linux? It freedom and flexibility. The Linux offers unparalleled customization and control over the operating system. Effective. Most Linux distros are free to use, reducing the software licensing cost. Community support. Linux has a large and active community that provides support and resources. Security. Linux is less vulnerable to malware and virus compared to other operating systems. Veracity. Linux can be used for desktop, servers, embedded systems, and more. Sorry. The variety and versatility of Linux distributions make them a powerful choice for wide range of users and applications. Whether you are a beginner looking for an easy to use desktop OS, or a developer needing a cutting edge platform, or an enterprise requiring a stable and secure servers environment, there's a Linux distro tailored to your needs. With its open source nature, robust security, and extensive customization options, like Linux continues to become a cornerstone of modern computing. Unix-based systems, a historical perspective. So the Unix-based system have played the pivotal role in the development of modern computing, serving as a foundation for many operating systems we use today. From their inception in the late 1960s, the widespread influence on contem- contemporary systems. Unix-based systems have shaped the way we think about operating systems, software development, and computer infrastructure. The birth of Unix is in 1969, developed by Bell Labs, and it was initially developed for the PDP 7 mini computers. The rise of the C and probability in 1970s, rewriting in C, licensing to universities, development of BSD in the commercialization and fragmentation in 1980s by commercial Unix systems. Companies like Sun Microsystems, HP, and IBM developed their own Unix variant for commercial use. The open source movement and Linux was in 1990s by GNU project by Richard Stallman launched the GNU project in 1983 to create a free Unix-like operating system. While GNU developed many components, it lacked a kernel, Linux kernel, and open source Unix variant. So the key features of the Unix-based systems are modern modular designs. Unix systems are built around small single-purpose utilities that can be combined to perform complex tasks. Multi-users and multitasking. Unix support multiple users and concurrent process, making it ideal for servers and shared systems. Portability. Written in C, Unix-based systems can run on wide range of hardware architecture. Stability and security. Unix systems are known as their reliability and robust security features. So the legacy of Unix is philosophy. Unix philosophy of simplicity, modernity, and doing one thing well continue to influence software design. Open source movement. Unix emphasis on sharing and collaboration laid the groundwork for open source movement. Foundation of modern compute. Unix-based systems underpin much of today computing infrastructure, from internet to cloud computing. The history of Unix-based systems is a testament to the enduring power of innovation and collaboration in computing. From its humble beginning at Bell Labs to its widespread influence on modern operating systems, Unix shaped the way we interact with technology. Its principle of simplicity and portability and modularity continue to inspire developers and engineers, ensuring that Unix legacy remains at the heart of computing for years to come. Whether through Linux, Mac OS, or BSD, Unix-based systems remain a constant of digital world. Now we will compare Windows Server Linux and Unix. So the features, likewise, the cost of Windows Server should be paid. License fee uh, we need to pay for the licensing. When we come into the Linux, it's free, it's an open source, but for the Unix based also it need to be paid for the various by vendor. Customizability is limited in Windows servers. When we come to the Linux environment, it's highly customizable because it's an open source. When we come to the Unix based systems, it's moderate. User interface in the Windows, mainly it is focused on GUI focused. When we come to the Linux and Unix based, it CLI focused. There are some optional GUIs available. When we come to the security, it's strong with the updates. When we come to the Linux distribution, it's strong with the community driven. When we come to the Unix based system, it's very strong the security. Use cases in the Windows Server, Enterprise and Cloud. For the Linux servers and development, Unix based are enterprise and research. The strength and weaknesses, when we talk about the strength and weaknesses, over the Windows servers, strength are user-friendly, strong support. Weaknesses are expensive and less customizability. When we come to the Linux distribution, strength are free and open source as well as customizable. Weaknesses of this is stepper learning curve. Unix-based systems' strengths are extremely stable and reliable. Weaknesses are expensive and limited hardware compatibility. Next, we will talk about Mac OS and iOS. Mac OS and iOS are two of Apple's most prominent operating systems, powering its line of Mac computers and mobile devices, respectively. Both operating systems are known for their sleek design, seamless integrated with Apple's ecosystem, and robust security features. So the Mac OS, the operating system for Mac computers. The overview is this is developed by Apple Inc. and initial release was done on 2001. Latest version uh, in 2001, the OS is Mac OS X. The latest version is Mac OS Sonoma as of 2023. Target devices are MacBook, iMac, Mac Minis, and Mac Pros. Key features will be user interface, Aqua interface, known for its sleek, translucent design and intuitive layout. Dock provides quick access to frequently used applications. Mission control allows users to view all open windows and virtual desktops. Integration with Apple ecosystem, uh, continuity features like handoff, universal clipboard, and AirDrop enable seamless integrations with iOS device. iCloud is synchronized files, photo, and data across all Apple devices. When we talk about iCloud, it's for the Mac. For the Microsoft, OneDrive is given. So the security gatekeeper ensure that only trusted software runs on macOS, and file wallet encrypt the entire disk to protect data. Touch ID and Apple TS security chips provide hardware-based security on support devices. Productivity tools like Finder, Spotlight, Safari. Developers support Xcode and Swift. Multimedia and creativity, Final Cut Pro, Logic Pro, Photo, and iMovie. iOS, the operating system for the mobile device. Developed by Apple Inc. and initial release on 2007. The latest version is iOS 18. Target devices are iPhone, iPad, as iPadOS, iPod Touch. Key features are user interfaces, touch-based interfaces designed for touch input with the intuitive gesture like swipe, pinch and tap. Home screen display app icon and widget for quick access. Control center integrated with Apple ecosystem, the security like Face ID, Touch ID, App Store, and the end-to-end encryption, productive tools like ProLab, Siri, shortcuts, multimedia and creativity like camera and photo, iMovie, GarageBand, developer support Xcode, and Swift App Store. So the advantages of macOS and iOS are seamless integrations, security, user experience, ecosystems. Challenges of macOS and iOS are hardware limitations and the cost is high and customizability. The both operating systems are less customizable compared to open source alternative like Linux. So macOS and iOS are integral part of Apple ecosystem, offering a seamless and secure experience across devices. Mac providing a powerful and versatile platform for productivity and creative on Mac computers, while iOS delivers a user-friendly and feature-rich experience on mobile devices. Together they exemplify Apple community to innovation, designing and user experience, making them key players in the world of technology. Next, we will talk about the mobile operating system, Android and iOS. Mobile operating systems are the backbone of the smartphone and tablets, enabling users to interact with their devices and run applications all among the various mobile operating systems. Like Android and iOS dominate the market, providing the majority of mobile devices worldwide. Android, the open source mobile OS, developed by Google based on the Linux kernel, initial release on 2008. Uh, Key features is customizability like home screen and third-party launches, default apps, hardware diversity with the wide range of devices, and the price range is budget when the main feature is Google integrate with the Android like Google services, deep integration with Google services like Gmail, Google Maps, Google Drive, and Google Photos. Google Assistant, voice assistant for tasks like setting reminders, search in the web, and control smart home devices. App ecosystem, Google Play Store and third-party app stores. Security, when we come to the security, Google Play protection, regular updates are given for the security purposes. iOS, the Apple mobile OS. Previously also I have talked this, developed by Apple Inc. and initial release on 2007. So, advantages of Android is customability and the hardware variety and Google integration. Advantage of iOS is user experience, security and privacy, as well as ecosystem integration and regular updates. Challenges of Android is fragmentation. The wide variety of devices and manufacturers can lead to inconsistent user experience and delay updates. security, while improving, Android is still more vulnerable to malware compared to iOS. And bloatware, some devices come with pre-installed apps that cannot be removed. Challenges of iOS is hardware limitations, like iOS exclusive to Apple devices, limiting user choice. Cost, Apple devices tend to be more expensive than many Android alternatives. Customizability is limited compared to Android. So the Android and iOS are the two leading mobile operating system, each with its own strengths and weaknesses. Android offer unparalleled customizability and hardware diversity, making it popular choice for users who value flexibility. iOS, on the other hand, provide a seamless and secure user experience deeply integrated with the Apple ecosystem. Whether you prefer the openness of Android or the polished experience of iOS, both operating systems continue to evolve during the innovation and sharpen the future of mobile technology. The last slide of the presentation, future trend and innovation in operating system. So the world of OS is constantly evolving, driven by advancement in technology and changing user needs. As well as we look to the future, several trends and innovations are shaping the development of operating system, making them more efficient, secure and variously. Below, cloud native operating systems define the design specifically for cloud environment, optimized for scalability, flexibility, and resource efficiency. Lightweight modular design, integration with the cloud services like AWS, Azure, and Google Cloud. Support for containerization and microservice. Examples for Google Chrome OS, Core OS, and Richer OS. Edge computing and IoT operating systems. Operating system tailored for edge computing and IoT devices enable real-time data processing and reduce latency. Artificial intelligence, otherwise AI integrations, operating system with built-in AI capabilities to enhance performance, security, and experience. Quantum computing operating systems designed to manage and optimize quantum computing hardware and algorithms. Enhance security and privacy. So the operating system with advanced security features to protect against involved threats and ensure user privacy. With the key features of hardware-based security, TPM and secure boards, and end-to-end encryption for data and communication, privacy-focused features like app tracking, transparency, and data minimizations. In the Windows 11 with TPM 2.0, iOS with app tracking transparency. Unified across platform operating systems that provide a consistent experience across multiple devices and platforms, including desktop, mobile, and IoT, with the key features of seamless integration and synchronization across devices. Universal apps that run on multiple platforms, shared development, frameworks, and tools. So, now the future of operating system is being shaped by combination of technology advancement and evolving user demands, from cloud native and edge computing to AI integrations and quantum computing operating systems are becoming more powerful, secure, and versatile. As these trends continue to develop, they will drive innovative across industries, enabling new possible and transforming the way we interact with the technology. So this is the end of fourth session. So next day we will talk about next day we are going to talk about the server roles and services. Okay, so we will meet on next Saturday around 8 p.m. Good day to all. Bye.